Today, I want to show that the sum of the natural numbers squared up to n squared is equal to n times n plus 1 times 2n plus 1 divided by 6. And if you don't quite understand what I'm saying, here I have the proposition written out completely. So let's get into our proof. And we'll be doing this with mathematical induction. So how do we begin when we're doing mathematical induction? Well, we're going to start with the base case. And our base case is when n equals 1. So all we're going to do is start with taking 1 and we're going to plug it in here. And if this is correct, we should get 1 in return because the sum of natural numbers from 1 to 1 is just 1, right? So this will become, let's write base case is when n equals 1, okay? So then we're going to take 1 and we're going to plug it in here. And we get 1 times 1 plus 1 times 2 plus 1 divided by 6. All right, and this will become 2 times 3 divided by 6. And this will become 6 over 6, which just equals 1, right? So that holds true. So let's write that down. This holds true. So then, from here, now that we know this holds true, we're going to assume that this is true for some natural number k. Now, assume this. When I write this, I'm meaning this up here, okay? I'm trying to save space by not writing this out completely. Assume this is true for some natural number k, or some k inside the natural numbers, okay? So now, what are we actually trying to show with this assumption? We want to show that this holds true, this up here, for some integer k plus 1, all right? So to write that out mathematically, we'll just say 1 squared plus 2 squared plus ... plus k squared plus k plus 1 squared equals, well, we'll take k plus 1 and we'll plug it into all our n's, and we get k plus 1 times k plus 1 plus 1 times 2k plus 1 plus 1, right, divided by 6. That's what we want to show. If we can show that, that will complete our proof, right? So let's begin with our assumption, right? And our assumption was that this holds true for some natural number k, or written mathematically, 1 squared plus 2 squared plus ... plus k squared equals k times k plus 1 times 2k plus 1 divided by 6. Then, from here, we're going to add k plus 1 squared to both sides, okay? So we get 1 squared plus 2 squared plus ... plus k squared plus, now we have k plus 1 squared equals this, right? So k plus 1, 2k plus 1 divided by 6 plus k plus 1 squared, right? So now what we're going to do is we're going to multiply this by 6, put this all into one fraction, and then expand it, and then simplify it down, right? Factor it, and then see what we end up with, right? That's what we'll do. So let's start with expanding this and putting this onto here, right? So we'll get k squared plus k, right, times 2k plus 1, right? Then over here we'll have plus 6k plus 1 squared divided by 6, right? Now let's expand this even further. And this will equal 2k cubed plus k squared plus 2k squared, right? Then plus k. Then over here we'll have plus 6k squared, that's a t, plus 6k squared, then plus 12k, and then finally plus 6 divided by 6. And I encourage you to check me on this, okay? Then let's put all the like terms together, and we get 2k cubed plus, well, let's see, how many k squares do we have? We have 1 right here, we have 2 right here, and we have 6 right here. You add those together and you get 9k squared, right? Then, let's see, here, let's cross those off, right? How many k's we have? We have a k right here and we have a k right there. Or sorry, k right there, 12k right there, that's 13k. And then let's cross those off. And now we have that plus 6. Okay? And then that'll be divided by 6. So now, how do we factor this? Well, I've already done the factorization. I encourage you to check me on it, though. I'm just going to rewrite it up here. All right, this will become k plus 1 times k plus 2. Let me make sure that's more of a k plus 1. Times k plus 2 times 2k plus 3. That's the factorization divided by 6. Okay? Then, I'm sure you can see it, right? Let's look at what we have up here, right? What we wanted to show and what we have down here. Well, this will equal k plus 1 times k plus 1 plus 1 times 2k plus 1 plus 1, right? And that's the same thing divided by 6. And that's what we wanted to show up here, and that completes our proof. Thank you for watching. Let me know if I said anything wrong. Let's not forget the little box. Thank you. Have a great day.